on screen and wait for everybody to start joining in. People are slowly moving in, so that's cool. I muted my stream as well, which is always good. So, welcome everyone, and welcome Chris and Michael. Thank you for joining me for answering these questions from the community. To get started, shall we start off with a question that was sent in? Who was the rookie that didn't mute the stream? Okay.
Me.
Just wanted to call that out. Okay, so the first question that we got in, and I think this would probably be a fit for both of you, is when providing a vault token to Nomad, what are some of the best practices to look out for? And is this something to rotate, policy whitelist, or blacklist? So maybe start off with part one, right? What is some of the best practices? Chris, do you want to kick it off?
Yeah. So the problem with vault is the problem you have with anything that's security related, which is that almost all of the ways that it can go wrong are ways that you don't necessarily know. If you do too much, then things don't work, and you notice and you relax a little bit. But if you relax it too much, you don't necessarily notice either. Let's start with the worst way to do it. The worst way to do it is the easiest way to do it, which is to fire vault up, hand the root token over to Nomad, and then go from there. Uh, Almost every single option that we provide. So if you go and look at the config stanza in Vault, the Vault config stanza for the Nomad servers and Nomad clients, almost every single option that's provided there is a contributor to the best practice. So if you go look at allow unauthenticated is one. That requires that a user submitting a Nomad job has to provide a vault token to say that they themselves have access to the policies which the job is going to require a token access for. That's there for a reason, right? It may not be a reason that you need, but you need to look at that and say, do I need that or not? If you look at policy whitelist or policy allow list or deny list, if you look at either one of those, you really just need to go down that entire list of each one of those and be like, is this something I need? Do I want to give people access to every single policy inside a Vault? Or can I afford to get by with an allow list, a whitelist for that? So on and so forth. The create from role. So you can set up a role inside a Vault, which is the role that all the tokens that are created and handed down to the clients are created from. And that therefore will limit it to a certain number of policies or not. You can just ask yourself, do I need to use a role to limit that, or is all of these are there. They're not all turned on by default, and we don't require them, but they're all there because they were in fact the best practice and the requirement for some customer, some user along the way.
Okay.
Michael, anything to add to that?
Yeah, no, that was perfect. I think the only thing that I would add is the to kind of address the token. So you need to give the Nomad servers a relatively highly permissioned token, like Chris pointed out, not the root token, the vault root token, please. But then the question is, okay, so it's not the root token. How should we rotate this token with Nomad? That part is more painful than we'd like it to be right now, especially because we recommend you don't put the vault token into your Nomad server configuration. We prefer you put it in an environment variable. It just makes it a little more secure. It's just a lot easier to kind of pluck things out of that configuration file probably than the Nomad server environment. But that does mean it requires a full restart of the Nomad servers to rotate that token. So this is not something where we would recommend a very short-lived token. Like, it shouldn't be hours, probably shouldn't be days. But hopefully you're comfortable rolling your Nomad servers. That's something you should be doing, every time a new Nomad release comes out anyway. That's something that Nomad is designed to do without any downtime, without any real negative impact to your cluster. If you do run into anything, give us an issue on GitHub. We try to hop on those right away. But for the most part, that operation, rolling restarts of your Nomad servers, is something you should be fairly comfortable with and should feel fairly low risk. It's really designed to handle that quite well. So, doing that in a matter of weeks or a matter of months, sort of, is probably a best practice there. And the easiest thing would probably be trying to coincide that with Nomad releases. So when you're having to roll your servers to update Nomad anyway, great time to rotate those tokens. Like I said, it's not the best scenario that we could offer, and it's something that we're looking to improve in the future. But for now, a relatively long-lived token compared to a lot of the other, very short-lived tokens that Vault is able to mint is probably the best practice.
Ideally, we would want to go to a system where Nomad would automatically renew its token itself, right? So you don't actually have to restart it itself, and it could have very short leases.
Nomad does renew its token. The Nomad server, once you give it the token, will keep the token renewed. But if you were talking about token rotation, just out of a concern, I guess I don't know if that's a security best practice in all environments, but to rotate the tokens just in case. Token rotation is a little more, but the Nomad server does keep its token renewed.
And I guess, like, to basically sum up, the advice is basically just limit the blast radius as much as you can by giving the least privileges is always the best thing to do with all of our products.
Yeah, an allow list is, almost always better than trying to create a finely tuned block list of certain things. That's going to kind of be a best practice just about anywhere, I think.
Yeah. So a question I saw earlier was someone asking if they could use Nomad in place of Docker Compose. What is your opinion on that, Michael? Oh, you're muted, Michael.
I am. Sorry about that. Yes, that's a great one. That's something I would love to have a better story around. Because right now, Nomad, it's just a little more involved to set up than something than a lot of your options with Docker Compose. You have the Nomad agent, but you almost always need the console agent as well in order to really use Nomad easily. And then to get that really nice secret story, hey, you need Vault too. So, there's a lot of components to kind of get what we would consider a minimum viable Nomad cluster set up. And that's kind of unfortunate. And we definitely spend a lot of time brainstorming how to improve this. We use Docker Compose internally today for a lot of our testing and development needs. It's a great tool. We'd love to have a better story around that today, but nothing specific I can promise.
Yeah. But to expand on that a little bit, one of the things that Docker Compose, especially early on, was good for is, if you just want to run a single Docker container, you can do that from the CLI with Docker, right? If you want to run an application that has multiple containers, it became necessary, unless you want to write a bunch of bash, to use Docker Compose. And Nomad, I don't know if I can say always, but certainly for the past number of years anyway, has always supported multiple containers, right? The whole purpose of different task groups is the acknowledgement that I want to have multiple things running as part of a job that aren't necessarily running inside the same container, the same namespace. So certain features of Docker Compose in terms of being able to spin up a multi-tier application via one run command are capable, are possible inside of Nomad today. It's one of these things that we're always talking about. Like, can we just go ahead and sit down, one of us finally one day, and just go ahead and write up some tool that translates, some subset of Docker Compose file into a Nomad job spec, and maybe for the next Hack Week, one of us will finally pick that one up.
That sounds pretty cool, actually. I've actually found myself, if I have multiple containers and they need to communicate with each other, especially if I'm doing a bit more advanced simulations like multiple networks, I very often go for Nomad immediately, just because the Connect integration just makes service discovery and communication so easy now that it's a no-brainer to use that for me.
Yeah, I'll personally say in giving talks on Nomad, when I'm doing slideware, uh, the ability to put that single line connect stanza inside of my job spec in PowerPoint, as opposed to 15 lines of console template, is definitely a winner.
Yeah. So
Yeah.
going into questions, right? I'm wondering, Chris, what is the question you get asked the most about Nomad?
A lot of it is people who've come from something like, maybe they've used something like Docker Swarm, or they use something like a larger, more framework level thing like DCOS or maybe Kubernetes, where it comes to the table with all of these different tools, and then they come over to Nomad, where you have the ability to build up your infrastructure in the way that that is appropriate for your environment, with or without the pieces that you need. And they need to know, how do I do this thing over here in Nomad? So they're trying to do something that Nomad doesn't provide as a first class capability, and they need to know how to do it. And the answer is, oh, you use this for Vault, or you use a console template stands, or use console for that, or use console connect for that. So almost all the questions really have to do something like that. I'm coming to Nomad, I want to use Nomad, but I need to know how to do this thing. I did it like that over here. How do I do it like this over there? So it's almost always is translating between one paradigm to the Nomad paradigm.
Makes sense as well. Like also for users that might not know schedulers yet. Like there's also the
Yeah,
translation, of course, of I have my binary or my web store application. How does that work with Nomad?
yeah. And so I'll give another example. It's, if you're coming to Nomad and you're trying to run an application, uh, it's a distributed scheduler is sort of a mysterious thing. You talk to the server, it's going to send the work out to a client node, and if that doesn't work, you don't know, did I do something wrong? Is there a problem with the scheduler? Is there a problem with the client node? So if you don't know how to run if you have a Docker job you're running, you don't know how to type the command on the command line, Docker run, and all the flags that you need to make it actually work inside of a Docker container just on your laptop, you're going to struggle to get it running on a distributed orchestrator like
Yeah.
Kubernetes or Nomad or DCOS or anything, right? So the first thing is, if you're coming, you're trying to run your application, which previously you were running on bare metal, you really need to know how to run it in a container before you try to throw it off to a schedule, because you're going to be swimming upstream while you're trying to juggle.
Yeah.
So you need to make sure, if you're trying to run on a Nomad via Docker, you need to make sure you know how to run on a Docker first, because a lot of the questions, those of you who monitor the mailing list, you'll know that, oh, I ran this and it exited with exit code 1. What am I doing wrong? Well, you have to make sure you know how to run it first. So that's a lot of the challenges, is really just the fundamental challenges of you're living in a distributed cluster environment now, and there are additional challenges you don't have when you're running stuff on your laptop or on bare metal.
Yeah. What about you, Michael?
The question being, what's the most common question I get about Nomad?
Yes.
Yeah. Yeah. I mean, why Nomad when Kubernetes exists? Let's just, jump right to it. Like, that is the number one question, and for good reason. No, Kubernetes is extremely popular. All the clouds have cloud offerings. It's amazing, not only from a software and engineering perspective, but it's amazing from an ecosystem perspective. And so, why Nomad when this exists? And I think this is something that we could talk about all day. So I'll try to keep it really short and focused. But I think the important notes that I always try to hit with this is that we don't intend for it to be an either or situation. A big part of our goal with things like Console Connect and our integration with that, and then with further console features that opens up, like mesh gateways, is that we always intend to work in whatever environment you're in. And so we expect that to be heterogeneous across orchestrators. We expect there to be a Mesos in there. We expect there to be a Kubernetes in there. Nomad will interoperate with services running in those clusters just fine. And so you can use Nomad where it makes sense, and use other systems where they make sense. Um, or maybe you're connecting to the things that are completely outside of orchestrators, and so having that really good console story is super important for Nomad, because we always intend to live in mixed environments, and I think mixed environments are how things are always going to be.
Yes.
And so that also brings in the whole hybrid cloud story. um, at a certain size, organizations are always going to be hybrid cloud. It just doesn't make sense to tie yourself to just a single cloud provider. Each cloud kind of has their own flavors of Kubernetes. Each cloud even kind of is starting to have their own flavor of multi-cloud Kubernetes stories. We intend to be just completely cloud neutral. We want to offer you the exact same user experience no matter which cloud you're in. We intend to let you connect between those clouds in a way that uses all the technologies you're familiar with, nothing special needed, no special support needed from the clouds. You don't have to wait for them to build something. We let you glue it all together today, hook in your data centers that you might have on-prem, all that sort of thing. We just aim to offer a unified control plane, regardless of what cloud you use, what on-prem you use, what are the orchestrators you use. We can hook it all together. And so that's where I think Nomad fits into this bigger picture.
Okay. I get asked that quite a lot as well, and now I finally have video material to send them to, so I don't have to try and answer it. So thank you for that. There was a question on Twitter, which I think might be interesting to answer live as well. So somebody was asking, Dear HashiCorp, and anyone who uses Nomad, has anyone out there actually replaced Rescue or RabbitMQ with Nomad Dispatch for customer populated queues? Which actually sounds very interesting. Have you heard of any use case similar to that? Either one of you? You're both pondering. I'm just going to say, Chris, go for it.
So when you put a feature like Nomad dispatch jobs out into the world, you dress it up, you pack its bag, and you put it out there, and people are going to use it, and they're not going to use it necessarily for the things that you were anticipating, and that's just how it's going to be. So people use Nomad dispatch jobs for a lot of interesting use cases. I can't say that I've run into anybody using it to replace something. I'm not familiar with Rescue, and I can't say I've seen them replace RabbitMQ with it. But Nomad Dispatch is interesting. It gets a lot of really out there use cases that we weren't necessarily thinking about when it went out.
What is the craziest thing you've heard people do with it? Are you pointing at me? Or at Michael?
I'm pointing at Michael. Yeah.
Okay.
All right. I can take this. Yeah, because it's something we probably could be a little more prescriptive about, to kind of avoid things. Because there is I'm never going to remember the issue number or anything off the top of my head, but I do remember a user coming to us doing exactly what this question is asking. They tried to replace, I forget if it was RabbitMQ, but some high throughput task processing queuing system, replace it with Nomad Dispatch, and they ran into some issues. And the reason for that is because Nomad isn't tuned for that sort of high throughput load as much as something like a RabbitMQ or things like that is, especially out of the box. And so you run into things like the rate at which we garbage collect jobs once they're done actually becomes really important if you're trying to use it as a high throughput job dispatching system. You want to tune that pretty low. Otherwise, you're going to build up, thousands, tens of thousands, hundreds of thousands, or more of these dead jobs in memory that you dispatched. And that's something that we probably need to be a lot more clear about as a gotcha. And the thing that makes it really tricky is that if you're running using the same Nomad cluster for high throughput dispatch jobs as well as service workloads, that sort of thing. These tunables are really going to be kind of fighting each other. Because usually for services, you like a really kind of long GC threshold for jobs, so that if you have a job stopped, or if you have an allocation crash or something like that, you have hours, if not days, to kind of investigate everything around that crash. And so if you tune the GC periods really short for high throughput, well, then it's going to make managing services harder. So I think it's one of those things where right now, if you're looking to use Nomad for really high throughput, sustained batch workloads, it can do that, and it can do that great. But I think you're going to want to keep that a distinct Nomad cluster from most of your service workloads, just because some of the things you might have to tune will kind of be at odds with what you need to tune for service workloads.
So, Schmeigel, question
I think
about the garbage collection. Like, with batch jobs, what is actually garbage collected? Because if you have like a prepared job, right, like a dispatch job, basically the outline of that is already there, and just the parameters that you pass in are different every time. So are the parameters then also stored somewhere for garbage collection, or would that actually perform quite well?
Oh, yeah, that's a really good question, and it kind of gets into nitty-gritty and implementation details. So for every dispatch job, we will for every job, we create allocations. Those allocations are an instance of a job. So if you have a job and it's count 5, we'll create 5 allocations for that. As you do deployments, as maybe allocations fail and get rescheduled, new allocations are created. Those allocations are kind of that first class object representing an instance of a job. And so those will build up really quickly, both on the Nomad clients running workloads, as well as in memory on the Nomad servers. And so that's kind of the first place where memory can kind of grow. An interesting optimization that we made sure to do, or I forget when, but it was around the same time as dispatch, kind of to help support it, is allocations used to actually embed a copy of the job. So that every time we create an allocation on the servers, we also create a copy of the job on the servers. We'd also send a copy of the job on the wire in the servers for all their communication. We put a lot of work into optimizing that. So now they're not making lots of copies of these jobs, and it's done a lot more efficiently, where they can just point to the existing copy of the job. So we've put a lot of work into making it as efficient as possible, but still, as long as you have one object per instance, if you're running a high throughput task processing system where you have tens of thousands, hundreds of thousands of things running through per second, that's going to create a lot of memory pressure on the Nomad servers, and you're going to want to tune carefully around that.
Makes sense. So an interesting question, and I'm just going to ask it to you, Michael. So, like HCS, when can we possibly see HNS?
Oh, keep asking. So for those of you not up on the latest HashiCorp acronyms, HCS is the console cloud offering, right? I'm talking about the right thing, Eric? Okay,
Yes.
good. The new cloud offering for console. So when are you going to get push button HashiCorp managed Nomad clouds? Keep asking. that's something we all want and we all dream of, but I am not the person who can make any promises about that today. But please keep asking, because we're really excited to offer that in the future.
Okay, and another question. Somebody in chat, they know Terraform Packer. Should they learn Nomad and ditch Kubernetes? I know you're both kind of biased, so yeah, that will.
Yeah, of course.
Yeah,
sure.
I mean, I think the short answer there too is, like all HashiCorp products, you could go to nomadproject.io, download the binary, no matter what OS you're on, you run Nomad Agent Dev, and you can poke at it. It's the costs to play around with it and kind of get some idea of what it is, how it works. We try to keep that as low as possible. We have example Terraform configs out there if you want to play with it in the cloud. We could do a better job of guiding people toward that, but that's a different story. But yeah, to just play around with it on your machine should be quick and easy and low cost. Both Kubernetes and Nomad are based on the Borg papers out of Google. Google's kind of internal scheduler that
And
really,
Omega too, right?
Yes. There's I think we still have a good resources page on our website that kind of lists some of these main sources. But yeah, point being, if you know Kubernetes or if you know Nomad, one will help you with the other. We use different terms in different places, and things are different. But conceptually, learning one will help you learn the other a lot too.
Yeah. A question about the Docker driver. Somebody is wondering, why is the entry point defined as a string list in Nomad as opposed to a string in Docker? Who is to blame for that one? Does that go all the way back to Armon, or?
If I say yes, is that a good enough answer? No, I'm kidding. It is interesting. I mean, Docker obviously we've supported since the beginning, so it may go back that far. The thing that I forget, and Chris, please feel free to hop in and correct me if you remember off the top of your head, is the thing that always gets me with the Docker driver is there's both the entry point and the command,
Yes.
and the arguments, and they all work a little bit differently.
Yes.
And so I never like remember questions about this off the top of my head.
Well, actually, internally in Docker as well, there's a lot of edge cases in where the combination actually reacts differently depending on what you input. Go ahead, Chris.
Yeah, I'm looking at the code now to see if I can come up with this. But this is, I got twitchy when you started asking. Anybody who's worked with any of the cluster orchestrators built on top of Docker, so whether it's Mesos or Kubernetes or Docker or Nomad, knows that entry point versus command versus args versus the whole thing is just fraught, and it's actually it's in a bad way. It's meant to make it easy to do things like Docker run, but at the same time, it's very fragile because it's based on understanding that not only do you know what's inside of the container, but you know things like what is the command that's configured in the metadata for this Docker image. And it's just this horrible dance that all the orchestrators have had to do for the past 6, 7, 8 years in terms of managing command versus args versus entry point, and making it be friendly, but also make sure that the full capability of that runtime is exercised. I'm looking right now though at this string and see what it is that we're doing with this string.
Well, I've actually run into problems myself where I've tried to in Golang override the entry point and then like wrap it in some other things, and we ran into the fact that if you pass the entry point as a string array or as a string, I don't know the combination anymore, because both can actually be both. And if you do some combinations, the end result is different. So it's not very idempotent in the input-output method.
Yeah.
I'm saying that it's a list of strings inside of the Docker client, the Docker API client that we're using. And I'm looking at the Docker API right now to see what it is that it actually is. But even inside of the, so I'll tell you what it is. If you look inside of the Docker Engine API, entry point is an array of strings. And if you, therefore, inside of the Docker API client that we use, FSUS's Docker API client for Go, it's an array of strings. And therefore, inside of the Nomad API, it's an array of strings. And in that case, if it wasn't an array of strings inside of Nomad, then that person who was used to using it as an array of strings for whatever their use case was that required that would then come to us and say, why is it not an array of strings? So I think it's an array of strings because it can be an array of strings. And it's just one of these use cases, unfortunately, where if you're writing your job specifications at that level, we're going to give you the full capability that we can, and just trust you to know whether you need command or env or arg or entry point or whatever.
Yeah, that's a really good point. Is that inside that config stanza, so you have job at the top level, then groups, then task, and then you have a task config stanza. And that config stanza on tasks is purely driver specific. So it's specific to even, if you're using Docker, it's Docker specific. If you're using the exec or Java drivers, it's specific to those. And it's specific to those in that it's usually tied very closely to the APIs or those runtimes. And so we try to stay as true to those underlying runtimes as possible. So like Chris pointed out, the Docker API specifies entry point as an array of strings. So we specify it as an array of strings, and it just gets passed through from that array of strings straight to Docker that way. The idea here being is, we don't want any surprises. If you're used to working with Docker, if you know the Docker API or are testing things locally just directly against Docker, we want you to be able to port that knowledge, that code directly into Nomad, have it work the exact same way. Anything else we do would require some sort of translation, and like Chris said, it might get surprising.
I'll walk my statement back just a little bit. It looks like the Docker API lets it be a string or an array of strings. And in Nomad, when we're parsing the HCL spec engine that we use to validate that HCL and make sure it's the right shape, it's going to want it to be one or the other. So we go ahead and stick with an array of strings, because an array of string can be a string if there's just one object, but a string cannot be an array of strings. That way lies dragons. Yeah, but you can, as Michael said, all of these runtimes are effectively a translation between what it is that the Nomad job spec is going to allow you to pass in the config and what it is that you actually want the runtime to do. And you can imagine, again, this is a thing that grows over time. The Docker config stanza didn't always have this many options in it, but over time, people come in with sophisticated Docker use cases as they're moving to Nomad from some other orchestrator, and they say, "Oh, I need to do this," and it's not part of that driver. It's not possible. So we add it in there, and we want to make sure that the full capability of that runtime is exposed to the users who need it. So
makes sense. So a question of something I've noticed sometimes when doing demos, where I create a lot of jobs that don't work. Like I do that a lot. Sorry. Sometimes it's like a meeting here. Sometimes it's confusing when I submit a new job after a job that has failed multiple times, that I don't immediately see effect of my new version getting deployed. And I'm assuming that is due to the timeout because of the job failing so often. But why wouldn't it, if I submit a new job, like trigger a redeployment immediately? Is there a reasoning behind that?
Did the job change, or are you expecting that the container changed behind the scenes?
The job changed. So I do see after a while, it gets picked up as a new version. It just takes a while, and I'm assuming it's like the back off timeout, but
I don't think that should be taking effect there. Yeah, I'd be interested in a repro of this, because that sounds like it might be a bug. It might
definitely file an issue.
Yeah. The reschedule stanza interacting with deployment in a way that we did not intend. Yeah, if you have a job that is unhealthy, its last deployment failed, that sort of thing, if you submit a new version of that job, so if you change a meta variable, environment variable, if you change just about anything in that job and resubmit it, it should redeploy immediately. At least I really can't think of anything that should delay that.
Yeah, new job means new evaluation, and new evaluations means it's time to create new stuff. The update stanza is going to dictate how the new things are created, But the gist is that a new evaluation will immediately result, and you should start getting some new allocations.
Yeah, one thing to maybe look for in this, and this is probably a good thing for everybody to be aware of, because even I forget this a lot. Nomad plan is everyone's friend. And the thing to really look for when running Nomad plan in this case is whether doing a Nomad run would be a destructive or in place update. Some changes to job specs, very few really, but some can be done in place, whereas most are destructive. Um, Things like changing the console service stanza, we can do those in place. And so what that means is no new allocations are created, no services are stopped, nothing is stopped, nothing is started. We just go ahead and update the console service entries according to this new job spec. For most other job spec changes, it's hard for me to think of other ones that we do in place. Most other ones will cause a destructive update. Destructive means we create new allocations, we go through all the deployment logic, all that sort of thing.
Okay. I see another question about Nomad telemetry, and it's quite long. So give me a second to very quickly pass through this. So one of the things that I've touched upon with you earlier, Michael, and maybe we can like do some on-air brainstorming on this, is it would be cool for some of the metrics if you could more specifically figure out to which job things belong. Like, are there some best practices that you two could maybe share with us on how to get the most out of our Nomad metrics?
Sorry, I'm bad at the mute button. Yeah, that's a great question. And this is one we get a lot of enhancement requests and questions, both from the community on GitHub as well as from our customers. So it's a story that we're constantly trying to improve, but know we have a lot more ground to cover. I think part of the problem, the fundamental problem that we face with our metrics, is that uh, the more labels we add, or tags, or how whatever your metric system calls them, but the more that we add to each individual metrics, the more useful they are, because the more easily you can kind of slice and dice your metrics along whatever dimensions are important to you. However, everybody gets to pay those storage costs, or at least has to pay some sort of operator costs to make sure they don't pay storage costs for these extra tags that we're including with our metrics. So in general, in the past, we've tried to include the right number of tags and labels, so that everybody kind of fit that 90% use case. Try to get everybody what they need. Maybe miss a couple things that would be nice, but make it easy so we're not overloading your time series databases. We aren't perfect, and we definitely want to make some improvements there, because we're still missing some things. And at the end of the day, we're probably going to have to add some more configuration tunables to the system as well, to allow people to kind of control what Nomad emits in general for these metrics, just because it's really easy to spew out a lot of data and cause operators a lot of pain to have to make sure they don't, if not overwhelm their time series databases, just start paying large storage and compute costs for metrics that they never use. So it's a really tricky balancing act. Please keep filing those issues. I promise you we read them and we care about them. They're super useful. You run more production Nomad clusters than Nomad engineers do. So we love hearing from users and customers about which metrics are the most important to them. And that feeds directly into not only code, but the guides that we write and the documentation that we write.
This is another one that goes towards, I don't know if y'all are seeing a theme that keeps coming back up, but it's the tuning towards scale. So when a request comes in, say a GitHub issue for a new metric like this, that's one of the discussions that happens every single time, which is what happens with a large scale Nomad cluster, a Nomad cluster with tens of thousands of nodes that's doing, all of this batch processing or something like that. What happens with the Nomad cluster this big if we start emitting what looks like one new metric? What's it going to do to the downstream infrastructure? So, being able to add these sorts of features can't break the scaling story. We're very sensitive to issues of scale, and so that's why until we have the ability to tune these sorts of things, we need to make sure that that the scaling concerns are considered, right?
Yeah, and I think
we can't. It's one thing to not have a metric that people want to have, but it's another thing to add a metric that people didn't need that blows up their Prometheus. If they don't have it tuned appropriately.
Oh, that makes sense.
Yeah, that reminded me of one other thing that kind of ties back to an earlier question. When I said that you run more production Nomad clusters when we do, that is probably true for a lot of our users and customers. But I do want to make sure people know that HashiCorp does run HashiCorp products on Nomad internally. I don't know how much more we want to get into that publicly, but yeah, there's a lot of Nomad internally running HashiCorp.
And I think when we look at metrics, right, and the metrics you want to get out of your system, a lot of those will probably be more related to the jobs you're running. And I think now that we have the new dependencies added to Nomad, and you can have the sidecars, I think getting metrics and logs out of your applications has now also become a lot easier to run than before.
Yeah, that's definitely a goal. And hopefully it's a lot easier to get, those more easily tunable aggregators and sidecars kind of set up alongside the tasks. So you can really have more fine-grained control in a manageable way of your metrics reporting.
And logs.
Yeah.
And everything else.
I have a new question. So it's a Nomad and CSI question. So I don't know which of you is looking forward to that one. With the new CSI plugin, does it mean one could run MySQL in a cringe container? Well, you unmuted yourself, Michael, so now I'm expecting you to go.
Yes. Yes. So let's be clear. We did make sure to keep the beta label on CSI for 011 because we are doing a lot more work around really validating the story for people and getting it up to kind of the high level of quality that we expect of features we ship. We really hope people are poking at it today. We really appreciate the people who are reporting bugs. We really want to get that beta label off of it as soon as possible. But yes, I mean, that's the goal. Stateful workloads like MySQL have always kind of been, let's say, problematic for whatever container orchestrator you might be using. But that's definitely an end goal for Nomad, is that we want to be able to run your stateful workloads, whether it's a MySQL, Postgres, Cassandra. People have been doing that with various stateful systems in Nomad for a long time. It's just more of a question of what your tolerances are. So one popular option for a long time, and you can Google some great talks on this actually, is people have run Elasticsearch clusters inside of Nomad and we have this ephemeral disk stanza that will make a best effort at migrating your data off of a node onto another node. If you're, say, draining a node and it's running Elasticsearch, we'll try to move that data for you. And that works really well for a system like Elasticsearch that has its own built-in replication and failover mechanisms. But Nomad, when it's able to do it, can do it a little bit more efficiently than Elasticsearch doing it. So that was always a good story. And basically what we've been trying to do ever since within host volumes and now CSI is just slowly expanding the use cases that we can cover around stateful workloads. So yeah, the goal is to be able to handle your workloads, whether they're stateless microservices or stateful databases. But it's definitely a journey, and it depends a lot on the exact characteristics of the stateful workload.
You want to add anything to that, Chris?
No, I do not. It's too early in the afternoon for me to be talking about storage.
If you had to run something with stateful storage right now on Nomad, what would your choice be?
Yeah, so I'll actually go first. You know, there was always the assumption that we wouldn't want to use storage inside of containers. The idea being that you would take workloads that needed reliable persistent storage. That's the issue. That's the problem that we're talking about, right? Containers have storage inside them. It's just not reliable or persistent. Yeah, there you go. So, and the reason that storage is hard as a problem for all cloud computing is because of the assumption that the things you're storing are important, right? Which means you really can't get it wrong. So if your Lambda is timing out too quickly, it might affect your latency, but you haven't lost your company, right? So storage is unfortunately it's a hard problem. That's why we have things like the CSI, which have gone in and said people like container, they like this pattern for these containers, and they want to be able to run everything in it. They want to be able to run their MySQL in it. And therefore, in order to do that, they need things like CSI to give them persistent storage. They need, CSI is nice because it gives us the ability to tap into the same plugins that you're using in other orchestrators like Mesos and Kubernetes. Keeps us from having to handwrite integrations for every single storage platform out there. So I would tell you just to move through the stages and do what it is that you need to do for the application that you need to write. If you don't need storage, then you don't need storage, right? So, you don't need it. If you can get by with something like ephemeral storage or host volumes on Nomad, that's a perfectly fine solution that people have been using for 5, 6, as long as Nomad's been out, right? That people have been using on Docker and Kubernetes and all of these other platforms. But it doesn't have the same sort of guarantees that other things do. If you lose your node and you were using a host volume, you've lost the volume. So it has a different reliability guarantee, but maybe that's okay in your environment. You know your environment better. But if that's not going to work, then yeah, I mean, if host volumes aren't going to do what you need them to do, then you're going to have to step up to CSI, with the caveat that CSI in Nomad is a new feature, and you're going to be on a journey with us as we try to figure out this thing that was written for Mesos, how well it works with Nomad.
Yeah, I think what you said, like, it really depends on your workload and what your requirements are. I think for a lot of people that are coming from on-prem, where they're used to running these kind of service on dedicated machines, like, you could do exactly the same with Nomad with host volumes, and that's a very decent solution if you're at least taking measures to make sure that it's backed up yourself, etc.
Yeah. I mean, if you were coming from a bare metal environment with an on-prem cluster and you've got your database writing to a disk that's on that machine, and something goes wrong with that machine and you're willing, as part of your remediation, to pull the disk and go move it to another machine, that's fine. And if the disk gets hosed, well, I hope you were prepared for that. Nothing about moving to a distributed workload orchestrator like Nomad is going to change. It's just going to change the reality that persistent storage is premised upon a requirement that you have things that you can't afford to lose. So you need to be prepared to set up the controls to manage that, whether you're in the cloud or on-prem, whether you're using containers or not.
Yeah. You have anything to add, Michael, or was that too early for you for storage as well?
That was great. That was great. I have spent way too much of my career fighting databases, so just the memories come flooding back whenever this comes up again. I think one other kind of maybe interesting historical context around all of this discussion when it comes to stateful workloads and orchestrators is that we are now years into microservices and stateless workloads being written for container orchestration. They are now native in this container orchestration world. We're not there yet with stateful workloads for the most part. Postgres, MySQL, these existing databases have been around decades in some cases. They're not native to these container orchestrators. And so it's always going to be very not just database specific, how exactly you get that configured and running in Nomad. But it's going to depend a lot on your use case of that database as well, because a lot of them are extremely flexible around how you configure them and what your system ends up looking like. So I am eager to see the world slowly move stateful workloads to be more orchestrator native. And I'm super excited that we have CSI now, because I think that'll be really important to make sure that Nomad has that seat at the table as these stateful workloads are figuring out how to natively support these orchestration solutions.
Yeah, I mean, it's only in the past couple of years that we've got Java to realize that it's inside of a container, right? So you should really think about that in the context of Postgres trying to count the number of spindles.
Okay. Another question coming from me. If you were using the entire Hashi stack, what would your order of operation be in bootstrapping the entire stack?
What do you mean if?
Well, obviously I am, but
my order of operation, step one, I go into Slack and I say, I'm installing the entire Hashi stack at home. Which one do I need to do first? And then one of the other engineers who is also running the entire Hashi stack at home will tell me, yeah, no, in the past you start with console, and then because then you can bootstrap your Nomad environment on top of console. You probably want that for service discovery anyway. And with Connect, you're going to get it's a lot easier, as you mentioned earlier, it's a lot easier with Connect because you get almost all the stuff you need with Connect. In the past, you would want console probably as your backend for Vault. So console first, then you can do Vault or Nomad in that order. Because you can always go back and add Vault and then reconfigure your Nomad to use Vault later on. So it's not crucial. I haven't actually set up Vault at home yet. I'm just still using console and Nomad. But yeah, probably console and then Vault and then Nomad. But now Vault has its own backend, but I'd probably just use console still as a backend for Vault. I don't know. Maybe I shouldn't say that out loud. It's easier to configure. So.
What about you, Michael?
Michael?
Nah, I think you got it. Yeah, console is kind of the backbone of the rest of the HashiCorp services, or it at least makes it a lot easier to tell. That being said, we are constantly brainstorming this bootstrapping question. We have a million great Terraform setups out there that you can search for and find, or linked off on Nomad Project.io for getting set up in the cloud with the Hashi stack. But at the end of the day, there's still this gap between Nomad agent -dev, where you play around on your own machine, and whatever the equivalent is in the cloud, to Terraform apply, and now you have a cloud customer. We still have this awkward gap. And it's this gap of, cobbling together, your console first, then Nomad using console, then Vault using console, then console using Vault, then Nomad using Vault. And it's like, this is a matter of code. We can automate this better. So we're working on it, but yeah, it's a tricky problem.
Yeah. Anytime TLS is in the picture, you've got a couple of hours of thinking and planning ahead of you.
To add to your solutions, though, if you run console on top of Nomad, Nomad will actually automatically discover that console is then running, and then still do everything automatically from that point on. So would you not want to start with Nomad then, and then run console on top of Nomad, so it's easy to update? And
I mean, there's folks who run Nomad on top of Nomad. So if you want to use it as your first level orchestrator.
Yeah, both console and Nomad use the same Go Discover library for using cloud, tags, labels, whatever your cloud's method of marking VMs to automatically discover one another's and cluster their setup, so you don't have to manually run server joins or manually configure IP addresses in your client configs, all that sort of thing. you can do in this abstract way with Go Discover. Since Nomad and Console both, have that same library, yeah, you can start with Nomad, and it can discover itself just as well as Console can discover itself. So we're obviously biased on the Nomad team, but all of our bootstrap brainstorming does focus around Nomad first, around using Nomad as the orchestrator to bootstrap Console, and hopefully, ideally, someday even Vault as well.
I see Chris pondering.
No, it's just all of the tools. It's not a monolithic, opinionated platform, the Hashi stack. All of the tools are built so that the people who are out there trying to solve this problem so that they can deliver applications, deliver value to their users, their customers, whatever, run Plex at home. I mean, all of these tools are built so that you can pick out the tools that make sense for you and deploy them in the way that makes sense for you. You can run the workloads that make sense for you. That's why Nomad's more. That's why we have the test drivers, more than just Docker. It's more than just Docker images, right? And so if you I would deploy Console first, but there are plenty of our customers who don't use Console, who just use Nomad. There are plenty of use cases where you don't need service discovery. Plenty of batch processing use cases where you just need to run jobs, right? You don't have ingress to worry about. So that's why we don't want you to have to deploy stuff that you don't need if you don't need it. So yeah, that was what that face meant.
All right. So we have another question from the chat on YouTube. What is the difference between Nomad and Rancher? Let's give the easy one to Michael.
Wait, this is. Oh, I'm afraid I'm not that familiar with Rancher.
Oh, okay. Let's pass it on to Chris then.
It looks very nice.
I was checking to see if Rancher is still around.
Yes, it is.
Yeah, I don't know anymore. So I used Rancher. I used Rancher at my last job, but that was back in the days when there was a company called Mesosphere, which had a product built around Mesos, and now they have a different name and they're built around Kubernetes. So I guess I would say in 2020, I don't know enough about Rancher anymore. I haven't looked at it in a couple of years, so I actually can't answer that question.
So from my understanding, Rancher has moved more towards a platform where you can orchestrate multiple Kubernetes clusters. And they also recently launched something that I believe would allow you to run a lot of micro clusters. So yeah, basically focused entirely on Kubernetes, and Nomad is its own scheduler is what I would say.
Yeah, that's one of the interesting things that's happened. Like, again, I'll pick on a Mesosphere company product that I really enjoyed using. One of the things that's happened as a result of the ascendancy of Kubernetes is that a lot of other companies have pivoted and they're just building things on top of and around Kubernetes. And there's nothing at all wrong with that. But it's sort of left a little bit of difficulty trying to find a niche. Say what Kubernetes problem am I going to solve for people, right? So it looks like maybe they're trying to tackle the long-standing problem of Kubernetes federation, cluster federation, which Anthos, I guess, is supposed to also address. I would say one difference is that Nomad federation has always been one of the things that we've taken care of. But I still don't. I don't feel like I can really speak to Rancher in any specific way.
I think this might be related to a topic that I've heard discussed a little bit recently, which is this idea of Kubernetes clusters as cattle, not pets, and this argument about whether that's how you should view things, because kind of the when container orchestrators, whether it's Mesos, Kubernetes, Nomad, or whether it's things like ECS, Fargate, Google Cloud Run, all these sorts of various options. When they came around, the idea is that your servers are cattle. They're not pets. You shouldn't. They should come and go. You shouldn't worry about them. and they can go away at any time. That sort of idea. So now the question is okay, now that we've agreed to that for servers, are clusters that way? And I don't know what the right answer is for everyone. I strongly suspect, as always, there is no right answer for everyone. Definitely with Nomad, the way that it has been designed from literally the beginning is with scale in mind. Both being able to scale down to very small clusters of just a few nodes. In fact, if you just want to run one Nomad server and run it as a client as well with workloads on it, that can work if you only have a dozen nodes or 2 dozen nodes in your cluster. That can be just fine. If that server dies, then you just can't make any scheduling decisions until you get that server back up again. So it's not HA, but it still has an okay story. And then obviously it goes to the other extreme then too. We have people running tens of thousands of nodes in a Nomad cluster, more. I'm not even sure anymore. So from Nomad's perspective, we definitely, as always, want our users to be able to decide whether this cluster is a pet or whether it's cattle. That's really not a question we're going to answer for you. But we want you to be able to have clusters that are tens of thousands of nodes in size without really thinking about it. Without really having to tune anything or change anything, whether from when it was 100 nodes inside or 500 nodes in size. And the entire story of the Hashi stack is that more or less, and I'm repeating this stupid metaphor so much, I kind of hate it. But all of your infrastructure should be trending more toward that cattle side, right? Your base infrastructure should be in Terraform. You should be baking golden images in Packer. And so from that perspective is whether you have a 10 node cluster or a 10,000 node cluster, you should be able to spin up a new one of those, fairly easily. Because you should have all of that infrastructure in code, deployable in a way that you iterate on every single day. That you do continuous integration with, continuous deployment with, and even disaster recovery if it comes to that. So yeah, I know we started out with Rancher here, but I think
we ended up with cattle. So
yeah, right. I guess. Oh, right. I get it now. I guess that's a story of HashiCorp's entire kind of infrastructure as code. Is that while we're not opinionated about exactly how you shape it and how you configure it and how you interface with it, we want to offer you all those tools to kind of design for that.
All right. Well, we are at time. So I would like to thank you both for joining me, letting me grill you with questions. I hope to see you soon again on one of these. And I hope everybody that watched this and in chat, which for me is down here, has enjoyed this. And I hope to seeing them again as well. Good night, sirs. Or good day to you. Thanks, everyone.
Yeah, thanks, everybody. Take it easy.